Hello, today we're going to work on operations with polynomials as well as functions. Now, they're the same thing. When I talk about polynomials, I'm talking about algebraic sentences and some of the problems that we're going to be working with. Some of the operations that we're going to be dealing with: addition, multiplication, division, and subtraction. Well, we can put subtraction with. Let me change that because I want to make them. Let's go with addition, subtraction, multiplication, and division. There we go. Okay. Now, we all know, we talked about in previous sections about the review videos about what a coefficient is, what a term is, what a variable is, and you put them together, you have basically an algebraic sentence. But what happens when we put those two together with operations? Well, it's not that big a deal. It's combining like terms. So we're going to combine like terms and multiply using, these two are using the exponential rules. The exponential rules are the rules that we used with the quotient rule, the product rule, and the inverse rule. And then these, we're going to be using combining like terms. Combining like terms. So these are things that you've seen before. Now we're just putting them together. All right, so I'm going to take 2x plus 4, and I'm going to add that to x. Oh, I'm not going to multiply, Hubert. I'm going to add that to x. I don't know why I want to multiply everything. I'm not wanting to multiply that. It's the second time I'm writing it. Plus 2x, 1x, minus 2. Now, in order to do anything with polynomials or with terms, you got to get rid of the parentheses. So I've got a 1 in front of this parenthesis, and I'm dotting it because it's there, because if it was a 2, you would see a 2. If it was a 0, it would take the whole thing out. So it's got to be 1. And this is a 1. So the multiplicative identity is 1, so it really doesn't change anything. But technically, when you distribute, you get rid of the parentheses. So now we've got 2x plus 4 plus 1x minus 2. Now, two things. One, I put a 1 in front of the 1x because I want you to see that we're combining like terms. Remember, this is a review. So most of you, as soon as I did that, said, oh, I know what he's doing now. He's going to combine like terms now. Yes, so you don't need the 1 there, but I'm trying to, go over this as a review so students will remember things as much as possible. And I'm trying to highlight. Give me a second. There we go. There's a like term with that term. And then this term looks like that term. And then you just combine like terms, and 2x plus 1x is 3x, and plus 1 minus 2, or 4, you have $4, you owe $2, you still have $2. Now notice I do not have an equal sign. In fact, this is a yield sign, and that's a yield sign because this is an expression. Okay, this is an expression, and if you remember in the previous video on algebra, we did solve multi-step equations. Here we are just doing like the left side of the equal sign, if you know what I mean. That's what we're dealing with. We're simplifying. So what about subtraction? Well, I'm going to put a big red circle around subtraction, and I'm going to put a circle around it, and I'm going to make that a red. Now, red means danger, and that means you better watch out with a negative. All right? It's the only one out of all four that you might mess up. Why? Because if you have a negative in front of a parenthesis, you have to distribute the negative, not just the number. So, x plus 3 minus 2x minus 7. Now, there is a positive 1 right there, and there is a negative 1 right here. Now, of course, those of you that remember how to do this, you're saying, good gracious, I know how to do that. Yes, but there are some that have forgotten this. And again, the review videos that I'm doing are not to teach people that know how to do it. It's to bring back the memories of this prior knowledge. In other words, if you've had this before, then you should be saying to yourself, oh yeah, I remember that. It changes the sign of everything inside the parenthesis. That's what these videos are for. These videos are not to acknowledge what you already know. These videos are to bring out things that you have forgotten. So, I'm going to distribute that positive 1, and 1 is multiplicative identity, so that really doesn't change anything. And then I'm going to distribute this negative, and I'm going to do it in red because I want you to see what happens. And we get, well, that's going to be x plus 3. And then we're going to have a red negative here and a positive here because that negative changes the sign of everything. And that's going to be a 2x and a 7. And now we take our highlighters and we've got x terms. And we've got regular coefficient terms. And I'm going to put a 1 in front of that x. You don't need it, but just to remember it's not a 0 because some people will say x minus 2x is negative 2x, and that's not right. 1x minus 2x is negative x. So yields negative x, and you can put a negative 1 there if you want to, but I wouldn't suggest it. And then 3 plus 7 is 10. How to multiply? Well, multiplication, and I'm gonna circle this one. I'm gonna circle this one with blue. Blue is not red, so it's not like important. It's unique because with multiplication, this is going to open up a whole new world. It's going to open up the distributive law for you. It's going to open up the FOIL method. And it's going to open up shortcuts, which you will learn more about in the Algebra 2 review. Okay? And I'll go ahead and mark the division because the division, we'll do it in burnt orange or something. This opens up a whole new world of factoring, which is the opposite of the distributive law. And it also opens up the whole realm of completing the square and the quadratic formula, which you're going to learn a little bit about today. I mean, not today, but in this video. Not this video, but Algebra 1 videos. So, out of the least complicated is plus, okay? When you add polynomials, that's about the least complicated. The one you got to watch out for is the minus, which is the red, because it can mess up that second step right there. You can mess that step up and get the whole problem wrong. Multiplication is going to open up a whole new world in Algebra 2 review, and division is going to open up a whole new world in the Algebra 2 review. So the multiplication and the division kind of opens up the world to the college algebra. Okay, so let's do a multiplication. And I'm just going to do a simple one because I'm going to do two methods. I'm going to use the distributive law and the FOIL method. So x plus 1 times x plus 3. And I'm going to use the distributive law. The distributive law says I'm going to multiply these two. And I'm going to multiply these two. And x times x is x squared. X times 3 is 3x. 1 times x is 1x. And 1 times 3 is 3. And these two, most of the time, will combine. And you get x squared plus 4x plus 3. Now that's using the distributive law. The distributive law is not restricted. Okay? It's not restricted. So put restricted and put a... You can use a distributive law with a binomial and a polynomial. You can use with a monomial and a trinomial. You can use it with a trinomial times a trinomial. The distributive law is not restricted. So if you ever come up to a polynomial, a four-term polynomial times a binomial, you can actually use the distributive law. Now the FOIL method is from the distributive law. It is a more methodical distributive law, and you can only use it with two binomials. Okay, you can only use it with two binomials. So it's restricted, but the FOIL method gives way to the shortcuts and give way to a form of factoring called reverse FOIL. So it is very important that you learn how to do distributive law as well as the FOIL method. And the FOIL method is as follows. X plus 1 times x plus 3. And x times x, that's your first out of each term. That's x squared. Plus 3x, that's your outer or outside. I is inner or inside. And last is 1 times 3. And you get the same thing. And a lot of people say, why use the FOIL method? I use the FOIL method, like I said, because the FOIL method will give you methods later on for factoring. So I don't tell you to use one over the other. I tell you to know how to do both. Make sure you know how to do both. All right, now, that's how you multiply polynomials or binomials or whatever you want to call them. Okay, hold on just a second. I want to make sure, turn my phone off. Not off, but blowing it up. Okay. And factoring, reverse FOIL, we're not going to get into that. But dividing, the only dividing I'll get into, because this is for later, the only dividing I'll get into is basically exponential dividing, is what I call it. And that is x squared plus 2x over x. And of course, that's an x to the first. So x to the 2 minus 1 plus x to the 2x, I'm sorry, plus 2x to the 1 minus 1, and that gives us x to the first plus 2x to the 0, which is x plus 2. So, and we talked about this in simplifying fractions. We talked about this. You could actually factor this out. X, and that'll give you x plus 2 over x. And then these factor out, and you get the same thing. Okay, so that's why you see factoring and division kind of going together. Now, we do get into long division, and I will touch on that in just a second. But I want to make sure you understand and remember that adding is combining like terms. Subtracting is combining like terms, but you got to be careful with that negative in the middle. When you multiply, right now in the Algebra 1 review, we're just going to focus on distributive and the FOIL method. We might get into a couple of shortcuts, but I'll just do an introductory to the shortcuts. And then with the division, just exponential division, which we just did, and I'll go into long division just right quick. I'll use the next page to go over long division. Now, I show long division because long division is not restricted. Synthetic division is restricted, so I don't spend a lot of time on synthetic division. So I like to show students one rule instead of two. So long division, there's only one thing that you have to remember with long division. With long division, you have to remember all place values must be accounted for. Okay? And that's the explanation. That is a big deal. Okay? Exclamation point, big deal. So let me give you an example. Let's say I take x plus 1, or x squared, minus 3x plus 7, and I divide by x minus 1. Now, you're going to find out later in factoring that you might be able to factor the top. You can't factor the top because 1 times 7 will never give you 3. So this is a non-factorable problem. But later on in Algebra 2 review, you might see a factoring type problem where you factor the top and cancel out. We'll get into that later, but this is not factorable, so we've got to use long division. So x minus 1 into x squared minus 3x plus 7. Now, I'm going to do something here, and I'm going to do it with a different color because I want you to see where the place values are. If you remember in Algebra 1 and Algebra 2, you're given degrees of a term. This is the second degree. I'm going to highlight these. I'm going to put these in. That's the second degree. That's the first degree. And this is x to the 0. This is x to the first, and this is x to the 0. So each term has a degree, and the leading coefficient is 1, and the leading term is x squared because it has the highest exponent. And that should be some stuff that you remember from Algebra 1. Now, each one of these place values should be accounted for. So this is x to the second, x to the first, x to the 0. So everything's there. X to the first, x to the 0. Everything's there. So we're going to count down. 2, 1, 0. 1, 0. If there was anything missing, you would have to fill it in with a 0x to the whatever's missing term. And we'll do one like that in just a second. All right, so now we just use long division. You focus on one thing with long division. You focus on this guy. You don't care about the -1. The -1 is like a kite a tail to a kite. The -1 is going to follow you no matter what. So you want to divide that x into x squared. Now you got to depend on your law of exponents here. product rule and quotient rule. Mostly the quotient rule because you're dividing. So the quotient rule, this is x to the first, and this is x to the second. How many times will x to the first go into x to the second power? X to the first, because 1 plus 1 is x squared. And that's how you got to remember the product rule. 1 plus 1 is x squared. And what's x times negative 1? Negative 1x. Now, let's go back to basic math. Over here. Let's go back to basic math. How do you divide 2 into 7? Well, 2 will go into 7 3 times. 3 times 2 is 6. And we always what? We always subtract. So I'm going to go out here, and I don't, since we've got more than 2 terms, I don't put the subtraction symbol out here like this. I distribute it. So I'm going to put a little x and make that a positive. Now, do you have to do either one? I don't care which one you do, but if you distribute the negative, you need to erase that big negative out there, the subtraction symbol. You can put the subtraction symbol out front and have a positive x squared and a negative 1x, or you can distribute the big negative and make it a little negative and a little positive. I don't care which one you do, but always what happens to the first column? The first column is supposed to go out with each step. It's supposed to go out. And your next, you owe $3. You have $1. Then you owe $2. And you bring the 7 down to help out. Now, how many times will x go into negative 2? Negative 2 times. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 3. We always subtract. That subtraction symbol turns this into a plus and turns this into a minus. And now we have negative 2 plus 2. That goes out like it's supposed to. And then 7 minus 3. And I'm going to make this blue because this is a remainder. 7 minus 3 is 4. And I'm going to put an R beside that because that's the remainder. Now, you've got 2 ways to answer this problem. One is you can say the answer, x minus 2, with a remainder of 4. That's one way, so that's one answer. And the other way is to write it as x minus 2 plus 4 over x minus 1. Now you need to write both, or you need to write both in your homework or your practice problems, because your homework or your test may ask for one of the other or both. And that's how you do long division. Now I'm going to do one next, and I'm going to have a term missing. So let's go ahead and write down one and do a term that's missing. So here we go. X squared plus 4 over x minus 2. Now see, this one, the degree, here we go. The degree of this one is 2, and then this is x to the 0. And then this is 1, and this is x to the 0. Oh, we got a missing term up here. We don't down here. This is fine. We got 1 and 0. That's fine. This one, we have a missing term. We need to have, I'm going to do this in blue, we need an x to the first power up here because we don't have one. So we've got to change it. So here we go. We're going to change it. And we'll write everything in black except for what we need. So x minus 2 into x squared plus 0x to the first plus 4. And now we're ready to start. And that's the only thing that you have to remember about long division. all place values must be accounted for. So all the place values are accounted for here. Let's see. Use your green. These are good. 1, 0. We started with 1, we got 0. Here we're starting with 2, but we went straight to 0, and you can't do that. You can't skip a place value when you're doing long division. So you have to make sure you put everything in there. So x will go into x times. X to the first times x to the first is x squared. X times -2 is -2x. You always subtract. When you subtract, that makes this negative and this positive. And of course, that goes out like it's supposed to. And 0 plus 2x is 2x. And then the 4 comes down to help out. How many times will x go into 2x? 2 times. 2 times x is 2x. 2 times -2 is -4. We always subtract, and that gives us a positive, and this goes out like it's supposed to, and we have no remainder. So this one terminates, and basically x squared plus 4 divided by x minus 2 is x plus 2. And that's how you use long division. Long division, the only thing you have to remember about long division is that all place values need to be taken up.